So we're going to do part two here. We have a block that has got two forces acting on it, and you're asked to find the mass of the block. But you're also told that the block's acceleration is 2 meters per second squared. So we know A equals F net over M. And if we do a little algebra, cross multiply by M, then divide by A, we get the mass is equal to the F net divided by M. Now, what does F net mean? We have a force of 12 going from the left. We have a force of 2 going from the right. So we're going to do the difference of the two. So it's 12 newtons minus 2 newtons divided by the acceleration, which is 2 meters per second squared. So we get 10 in the numerator and 2 in the denominator. And divided by 2 is kilograms. So we get choice 2. The next one is which body is in equilibrium. So with equilibrium, the F net must be equal to 0. So that means that it must be going in a straight line at constant speed. Okay, aka a constant velocity, which doesn't necessarily mean a constant speed. Okay, the straight line part. So a satellite orbiting the Earth, okay, circular orbit, is changing direction. Okay, so that can't work. And a ball falling freely toward the surface of the Earth, okay, it's accelerating at 9.1, so that can't work. A car moving with a constant speed along a straight level road, okay, that seems to fit the bill, and that's our answer. If we're trying to find the weight of an object that's got a mass of 2 kilograms on the surface of the Earth, that's the force of gravity. And we know that Fg equals energy. So we have 2 kilograms times 9.81 per kilogram. So that gets us our 19.62 grams. So choice 4. Number 13, a 70-kilogram cyclist develops 210 watts of power while pedaling at a constant velocity of 7 meters per second east. What is the average force? Okay, so we know there's a relationship in the reference tables. P equals work over time, so the rate of energy transfer divided by time. But work is FD, so it's FD over T. And then we also say that D over T is our average velocity, so it's force divided by velocity. So we have P equals FV, and we're asked to find the average force. So I want to get my F. So I divide by V, divide by V, and that would be my 210 watts divided by my V of 70 meters per second. So notice that in this, the 70 kilograms doesn't make a difference. And 210 divided by 7 is 30 minutes. So we get 30 minutes. Choice 2. If we're trying to find 14, the gravitational potential energy of your PEG, that's equal to mgh. So that's by object development, not the object. Okay. So look at what's in here. Okay, well, m's in there, gravitational strength's in there, and h. So if we look at which of those fit the choices, well, acceleration's not part of that. Okay, momentum is not a part of that. Speed is not a part of that. So the only thing that's in there is position. Number 15, as a ball falls freely towards the ground, its total mechanical energy. Well, we know that total mechanical energy, this is the idea of being conserved, is that it always remains the same. Okay, never increases, never decreases. So that's a definition on total mechanical energy. Number 16, a spring with a spring constant of 4 newtons per meter is compressed by a force of 1.2 newtons. So we have F of 1.2 newtons. We have spring constant K of 4 newtons per kilogram. That's going to be newtons per meter. And we're asked to find the energy stored present in spring with PES. So I know PES equals 1/2 kx squared, but I don't have the extras yet. But I also know that Planck's law is the force on the spring equals kx. So with says a distance of 1 meter separates the center of two small charged spheres. The sphere exerts gravitational force Fg on an electrostatic Fb on each other. The distance from the sphere's centers increased by 3. So what we want to do is we want to ask ourselves, is Fg equal to G F1 and F2 over R squared? And Fv is equal to K Q1 Q2 over R squared. What are we doing for the distance to go from 1 to 3? And so we are tripling. So if I triple R, then if this goes up, then we know that this has got to go down. And if this goes up by a factor of 3R, then the force has got to go down by a factor not just 3, but 3 squared, since my R is squared. And the same thing over here. 3 squared is 9. So both of them get reduced by a factor of 9. So here's one. Number 18, the electrical resistance of a metallic conductor is inversely proportional to. So we look at the equation, RL over A, and if we want to look at an inverse relationship, well, there it is. R and A. R is by itself, and A is the element. So cross-sectional area. Here's 3. In a simple electric circuit, 24 ohm resistors connected across a 6-volt battery. What is the current? Well, we know R equals V over I. So if I want to find the current, I'm going to cross multiply by I and then divide by R. So I get I equals V over R. So I have 6 volts over 24 ohms. And so I get a current of a quarter of an amp, 0.25. 20, an operating 100-watt lamp is connected to a 120-volt outlet. What is the total electrical energy used by the lamp in 60 seconds? Well, energy is equal to power times time. But power, based on given P, given V, and we're trying to find electrical energy W. So if I know the power of 100 watts and I know the time of 60 seconds, I can just multiply the 2 and get 6,000 joules. And what is 6,000 in scientific notation? That's 6 times 10 to the 3. Number 21, we have an electron beam, okay, going in, so the electron is negative. And we want to know what way does it experience the force of the electrons. So if this is an electron is attracted to the positive because opposites attract. So the force is directed towards the top of the page. 22, which statement describes the gravitational force and magnetic force acting on magnet A? Well, if the magnet is just sitting there, then we know that there's always a downward force of gravity. Okay, then there must be some upward force, and if there's 2 magnets, the upward force must be called magnetic force. So don't get too worked up over the B and the magnetic field, and those two have to be equal. Okay, so the gravitational field is attracted to the Earth, and the magnetic force is repulsive. It looks like choice 1. If we're trying to figure out which color of light has a wavelength of 5 times 10 to the minus 7 meters in air, that's my wavelength. And so what I'll need to do is I'll need to find my frequency that corresponds to that. So because in our reference tables, the colors of light are defined as their frequency. So if I divide by wavelength, I have to ask myself, what V am I talking about? Well, that would be the speed of light. So 3 times 10 to the 8 meters per second divided by 5 times 10 to the minus 7 meters. And if you do that out and then look up which color that frequency corresponds to, see 24, which type of wave requires a medium through which to travel? Well, television, X-ray, and radio are all light, which can travel through a vacuum. Sound. Do you remember the bell jar? The bell cannot, if it's in an evacuated chamber, then you cannot hear. A periodic quadratic wave is produced by vibrating the tuning fork, the amplitude of the wave would be greater than 2.4. Okay, so the amplitude is the amount of energy. So, based on the tuning fork, it's how much those forks are moving back and forth. So how can we get it to move back and forth? Got to strike it harder. Number 26, the sound wave produced by a trumpet has a frequency of 440 hertz. The distance between the successive compressions in the sound wave is travels. So we're looking for the wavelength, right? The distance between successive compressions. So if we look at it as these are compressions, we want that lambda. Now it's sound. So once again, we know how fast it's traveling. We just need to figure out what the wavelength is for that frequency. So lambda equals v divided by f. This is 331 meters per second. So you sound out that of light divided by the frequency of 440 hertz. If you do that in your calculator, you get 3/4 of wavelength, or 3/4 of meter. These are those tricky questions that you have to be careful of. It says that the angle between the glass and the air is 30 degrees, but it's asking for the angle between this light ray and the reflected light. So it's really asking for that angle. And if this is 30 and the normal's drawn, so it's perpendicular, so that's 90, then we know that the incident ray is 60, therefore the reflected ray is 60. And if we want to get the total angle, then 60 plus 60 is 120. In which way does blue light change as it travels from diamond to crown glass? Well, if it's going from diamond, high index of refraction, into crown glass that's got a low index of refraction, then what we need to do is we need to say, first of all, looking at the wave equation, we know that the frequency does not change as it goes from one index of refraction to another. So 1 and 2 can't be equals. And we know that diamond, okay, or in general, light travels faster in lower indices of refraction. So we have going from high to low, we know that the speed must increase. Okay, and that's a definition of light. All transverse waves travel faster in lower index refractions than do in higher index refractions. All right, so stay tuned for video 3, and we'll see you then.